Okay, now we're going to go over questions 10 through 12. We're just going to lump them together. So this says a tennis ball is hit in the air from a height of 1 meter. The function h equals negative 4.9 t squared plus 20t plus 1 models this situation. The function is modeled in the graph below. Note the scale. Okay, so I've got time along my x-axis, which we're calling t, height along my y-axis. I notice that the height are going in increments of 2 feet, whereas time is going in increments of 1 second. Okay? So number 10, what is a reasonable domain for this situation? Reasonable domain for this situation. We know for a quadratic function that the domain is always all real numbers. But this is an actual real life situation. Okay? So domain, my x values in this problem is time, t. Okay? So likely, where does time begin and where does time end? Well, the story begins with time is 0. And it ends when the tennis ball hits the ground, right? It's not going underground. So it ends here. So a reasonable domain would be from 0 to, let's say about like 4.1 seconds approximately. Okay, so I could say bracket 0, comma like 4.1. Okay, and I'm using brackets because time does begin at 0 and it does go. We don't have open circles, okay? Or I could say 0 is less than or equal to t is less than or equal to about 4.1. 2 ways of saying that. Okay? All right, what is a reasonable range? Reasonable range, okay, so that would be the y values. And the y here is h, or height. Okay, so we really need to consider this. Where does our height begin, and what's the highest point it reaches? Because we know there's a maximum, right? Well, the height does not begin at 0, right? Where does our height begin? And the clue is actually given in the equation and in the problem. A tennis ball is hit in the air from a height of 1 meter. So that's where it begins. So we're starting at 1, and the ball's going up. So what's the highest point it reaches? Right here, which, I mean, we could calculate what that is, but if we're given the graph, we're supposed to use the graph. So let's just estimate about 21.5 feet. We'll just say that's 21.5. Okay, so a reasonable range would be from not 0, because the tennis ball is starting at 1 meter, and it's going up to a maximum height of about 21.5, we'll just say. Or we could say 1 is less than or equal to h is less than or equal to 21.5. Okay? Okay, and last question, number 12. When does the ball reach its maximum height? When? Okay, so I have to know, what is this asking me? It's not asking me what the maximum height is. It's asking me when. When means time, right? So this is, if the vertex is my maximum height, and I want to know when, I'm looking for the time. So what is the time when it reaches its maximum height? After, looks pretty easy, 2 seconds. Okay, so when does the ball reach maximum height? I'll put after 2 seconds. Always making sure that I use the correct units. Okay.